learners, today we are going to solve paper 1 core of May-June 2020, paper 11. So we have this number 1. Write down the value of the 7 in 570,296. So we need first to know the place value of our digits. The first one, this one is a decimal point. This one is the unit digit, 6 units. The second one is the tens unit, so you have 90. The third one is the hundreds, so you have 2 hundreds. The fourth one is the thousands, so you have 0 thousands here. And the 7 is the 10,000s, so you have 7 10,000s. This one is the 100,000s, so here we have 500,000s. So for 7, we are going to round off here the 7. So the place value of our 7 here is 7 10,000 or simply 70,000. Have number 2, the mean. So for the mean, we are given the table here. We have January is 9, February is 11, March is 15, April is 19, May is 23.5, June is 27.5, July is 29, August 28, September 25, October 19.5, November 14.5, and December is 10. So here we have 12 months because this is 1 year. So the question is, calculate the mean of these temperatures. So what do you mean by mean? Mean, in layman's term, it is called also the average here. So how do we compute for the mean or the average? To compute for the average or the mean, we get the sum of all the scores or the temperatures here, and then we divide it by the number of temperatures. In this case, we have 12 months. Let's get the mean now. So to get the mean, we get the summation of temperature. So we're going to add the temperature from January, which is 9, up to December, which is 10 degrees Celsius. If we are going to add these 12 temperatures, our total will be 231 degrees. That's the total, 231 degrees Celsius. Now to get the mean, we'll just divide it by 12 because we have 12 temperatures. And the temperature mean here is equal 0.25 degrees Celsius. Number 3, we have the following fractions, percent, and number, decimal number, and we have another fraction there. So here, we are going to arrange them so that on the left side, we have the smallest. And sometimes we don't have the toward smallest here. Only the symbol of this one is greater than this one is greater than this one. So we don't really if they are going to write the smallest or anything here. So then don't expect this one. So here, we will write them all in decimals. So this one is already 0.065. This one is easy, changing percent into decimal. We divide it by 100. Therefore, we're just going to move our decimal point 2 places to the left. 1, 2. So this one is 1, 2. We add 0, so we have 0.56. Okay. For this one, we divide 13, divide by 201, and we have 0.0647. So we have 0, 0. So we have 0.64, we have 0.56. This one is still this one, the same. And we divide 5 over 89, and for 5 over 89, that would give us 0.562. Now in this format class, we can determine now which is the smallest and which is the largest and which numbers are in between. So here we have 64 here. We know this one is 6, this one is 5, okay, this one is 6, so that's 2. So 5 again here. So we just compare the smallest, which is 056 and 0562. So because of the 2 there and this one is 0 here, so this one is smaller than that one. Therefore, this one will be the smallest. So we will write not this one but the original given. So here we will write 5.6 and then the percent. Do not write 0.0560 here. Write the original. And then after that one, we know this one is the second because these two are 6. So here we have 5/89 here, and then the 2. We are going to compare the 0647 and 065. This one is 650. This one is only 470. Therefore, this one is smaller. So we write here 13 over the 201 here. And then last is the largest, which is the 0.065. Okay, you write the original given. Here we have the lines of symmetry. What do we mean by lines of symmetry? That line, when you put that line, we can fold that figure into that line, just like a heart. If we have a heart, there is only one symmetry for heart, and this is that line, so we can fold it there. Okay, we can't have a line of symmetry which is horizontal for a heart because we cannot fold that one, and this it will become just like one piece. So here it is stated here that this one is an equilateral triangle or equiangular triangle, meaning the sides are equal. This, and this, the three sides are equal, equilateral, or the three angles are equal, 60, 60, and 60. This one is also called equiangular. Now, to draw the lines of symmetry, we have how many lines of symmetry here? We have one. We can fold it here like this, or we can have our line of symmetry here, which we can fold like this one. And the other one is we can fold this one here, like folding it up. So we have here three lines of symmetry. Now here in this figure class, we have only one line of symmetry. We can't have our line of symmetry here because we cannot fold that one there. So our line of symmetry here is this one here because we can fold it like this, and we have one figure only. Okay, they will overlap or they will coincide. Okay. For letter B, we have the rotational symmetry. We rotate it usually in a clockwise direction. So when we rotate this one, this one will go there and this one will go here. So that is one, and then another one, and this one will return back to its original position. Therefore, the rotational symmetry of this figure is 2. We don't have a rotational symmetry of 1. Usually it starts with 2 or 3 or 4, but not 1. Okay, number 5, we have this problem. We have this figure here, class. So we have a triangle here, and we have this symbol. What do we mean by these symbols here? A mark. It means that these two sides are congruent or equal. So what do we call a triangle which has two equal sides? We call that an isosceles triangle. So in an isosceles triangle, we have the vertex angle, 1, and we have two base angles. The base angles are equal. Okay. The opposite of these two equal sides are also equal. If these two are equal, then its opposite angles are also equal. So here, opposite of this one is this angle here. Let us put a mark also. Okay. And the opposite of this one is this angle. So this one, this and this are equal because the opposite sides are equal or congruent. Now, these two equal angles, they are called base angles. This one is called the vertex angle. So, we are to find this angle here, ACD or DCA here. So, what is the measure of this angle? So before we can solve this one, we need to find this angle here, which is the same or equal to this angle. So to find that one, we know that in any triangle, the sum of the interior angles is always equal to 180 degrees. So here class, we will subtract this one from 180 degrees. So we have 180 degrees minus the 38 here. So here we have 2, so 7, so we have 142 degrees for this two, but they are equal. Therefore, we are going to divide this 142 degrees into 2. So dividing this 142 degrees by 2 will give us 71 degrees. Therefore, this base angle here is 71 degrees. The other base angle is also 71 degrees. Now, how can we solve ACD? Now, can you see that this one is a straight line? When we have a straight line and we have angles in the straight line, the sum of these angles there, whether we have only 2 or 3 or 4, is always equal to 180 degrees. So when we have 180 degrees and we have already 71 degrees, what do? Is we just subtract 71 degrees from 180 degrees. So here we have 180 degrees. What is this 180 degrees? That is the angle in a straight line. We subtract this one minus the 71 degrees here. So here, so we have, okay, this one is 10, this one is 7. So 10 minus 1 is 9 degrees, and the 7 minus 7 is 0, and then we have 1. So this one is 109 degrees. Okay, number 6. We have a flight, an airplane takes a flight from Madrid to Buenos Aires. Okay. The plane departs at Madrid local time in Madrid 20:55, and then it arrives in Buenos Aires at 3:50 local time in Buenos Aires. So, but the time in Buenos Aires is 5 hours behind. So it means that the time in Madrid is 5 hours ahead. So we're just going to compute that one. What are we going to find here? Work out the time the flight takes. This is our time in Madrid. We need to convert that one to local time also of Buenos Aires. So for Madrid, in Madrid, we will subtract 5 hours because this one, Madrid is 5 hours ahead. So let us subtract 5 hours from 20:55. So for 20:55, so let's do that one here. So we have 20:55 in Madrid. This is 5 hours ahead. To get the equivalent local time of that one with Buenos Aires, and then we subtract 5 hours here. Okay. So here is 55 also, minutes. Do not subtract that one from minutes or minutes from hours. And then 20 minus 5 is 15:55. And then here is 350. But the 350, meaning we are going to add 24 here. Okay, so we add 24 hours here. 24 hours. Let's convert that one to 24 hours. So this one is 27 and 50. That one is the hours in Buenos Aires. Okay. Now, what we're going to do is we just subtract this one from 27. So we have here 2750 minus this 1555 here. Now, we are going to subtract, but how can we subtract 50 from 55? We must borrow 1 hour from 7 and put it here. That 1 hour is equal to 60. So we are going to add 60 to 50. So this one will become 26, and this one is 60 plus 50 is 110 minutes, and this one is still 1555. Okay, we subtract now. We can subtract because this one is smaller than 110. So subtracting 155 from 110 gives us 55 minutes, and then hours and hours. So we have here 11. So it takes 11 hours and 55 minutes to fly from Madrid to Buenos Aires. Here. 6B. Diego changes 200 euros into Argentine peso. The exchange rate is 1 euro is equal to 24.8 pesos. Work out how many pesos he receives. So let's have 200 euros. Put here 200 euros, and then we put 1 here times. We put the euro here, so we can cancel it and change into pesos. Now we put here the euro, and then the pesos is here. Okay, pesos there. So this one is the conversion. So our conversion is 1 euro here is 24.8. So 24.8 is here. 24.8. So we cancel the euro. So our unit now is in pesos. So we just multiply 200 times 24.8 will give us 4,960 pesos. 6C. The distance of Madrid to Buenos Aires is 10,050 kilometers. The return flight of Diego takes 12 hours and 30 minutes. Calculate the average speed in kilometers per hour for the return flight. Now we have our formula for uniform motion, which is distance is equal to velocity times time. Here. So our velocity here, if we are going to compute for the velocity, we divide this by time, we divide this by time. So our velocity is equal to the distance traveled divided by the time. In here we have already the distance, which is 10,050 kilometers. We have 10,050 kilometers here. And our time is 12 hours, but we have minutes. So we need to convert minutes to hours and add that one to hours. So this is something 12 point something hours. So we change first minutes into hours. So how do we change minutes into hours? That is, okay, can I use this one, class? That is 30 minutes. We divide it by 60. And that one will be equal to 0.5 hours. Our unit now is in hours. If we want to change seconds into minutes, we divide it by 60. To change minute into hours, we divide it by 60. So that 30 minutes is equal to 0.5 hours. Then we add that one to 12. So our time is 12 0.5 hours. This is in hours without any minutes anymore. So when we divide that one, the velocity of the plane in its return flight is 804 kilometer per